Previously, we have shown that for certain fields, we can classify regular Hermitian space by dimension and discriminant. A corollary of this is that in the case of finite field, Hermitian spaces can be completely classified by the dimension. Contrast this with the case of quadratic spaces. Remember, for quadratic spaces of a finite field, we need two invariants. We need dimension and discriminant to classify it. The general principle is that one can generally expect a question for Hermitian spaces to be easier than the analogous question for quadratic spaces. Alright, so let's see why all regular Hermitian spaces of the same dimension must be isometric. Well, by our previous result, it suffices to show that they have the same discriminant. Okay, so let's say that V is a Hermitian space of dimension n. So V is isometric to this. V has a splitting like this, right, in some bases. This is a basis as an E vector space. Now E is F adjoining I, so as an F vector space in this basis, we will have this splitting. Why is that? Because, for example, Q of I V1 should be equal to I squared Q V1, which is lambda A1. And so the determinant of this is, well, it's just lambda to the n, because when we multiply this, each ai appear twice, so up to a square, this is just lambda to the n. And thus we see that all the Hermitian spaces of dimension n have the same discriminant, it's just lambda to the n, and so they must all be isometric.